Welcome everyone. Uh, this week's online live session. So this week I'll be discussing some problems related to differentiability and its applications. So let's start with our first problem. So this is our first problem. You have to find values of m and b given that the function is differentiable at x equal to pi. Okay. Now, since this function is differentiable at x equal to pi, this must be continuous also at x equal to pi. Okay. Okay, let me write what is our function. So our function is fx equal to sin x if x is less than equal to pi. Okay, so okay, so I'm discussing this problem, first problem. Okay, so in this problem, this is your function, the given function, and you have to find out the values of m and b given that the function is differentiable at x equal to pi. Okay, so this is our function. So sin x when x is less than pi, and mx plus b if x is greater than equal to pi, right? And it's given that f is differentiable at x equal to pi. Okay. Now, since f is differentiable at x equal to pi, f is also continuous. F is also continuous at x equal to pi. Okay, now since f is continuous at x equal to pi, that means the right hand limit of this function and left hand limit must be same. So if you take the left hand limit of the function, that must be sin pi, and it should be same as the right hand limit x tends to pi plus of our function, which must be m pi plus b, right? Because on the right hand side function is given by mx plus b. This equation gives that m pi plus b must be 0, right? Because sin pi is 0. So this is equal to 0. So this is our first equation for finding the values of m and b. And now we use this condition of differentiability, right? Because the function is differentiable. Now notice that if x is less than pi, then you can differentiate the function, right? Okay, so okay, now we will use the condition of differentiability. Now function is differentiable. That means again this limit, if you take at pi, limit of this function divided by h, where h approaches to 0 from the right hand side, this must be same as limit h approaching to 0 from the left hand side of again f of pi plus h minus f of pi divided by h. Okay, and instead of taking here h to be positive, in this case h is positive, we can replace h by minus h. No, in this case h is negative, so we can make it positive, right? H is negative, so in this particular case, take h equal to minus k. Let find out this limit explicitly. Limit h going to 0 plus what is f of pi plus h, because pi plus h is greater than equal to pi, right? Notice that pi plus h is strictly greater than pi. So here the definition is mx plus b. The function is given by m pi plus h plus b minus m pi plus b, right? Because this is the value of function at pi and divided by h. So we are finding this right hand limit. So this limit must be, you can see that m pi will cancel with m pi. This limit is equal to 1. Okay, after all the cancellation you'll get that this limit is 1. Okay, now we'll find the left hand side limit, that is this limit h going to 0 minus f of pi plus h minus f of pi divided by h. And now notice that in this case h is negative. Okay, so in the right hand side h is negative, therefore this pi plus h is actually less than pi. Okay, so this is not a positive quantity, here h is negative. This you should note that h is less than 0, and therefore if we apply the first definition of the function, which is applicable when x is less than pi, and on the left hand side f is given by sin x function, right? It's a sine function, so this is sine pi plus h minus sin pi divided by h, and limit h going to 0. Now again sin pi is 0, so we just have that limit h going to 0 minus. Now since h is negative, sin pi plus h is same as, okay, sin pi plus h is same as sin of h. Okay, so there is a little bit mistake here. This is not sin pi. At pi, the function is given by, again, m pi plus b, right? So this is m pi plus b. So we can write it m pi minus b. Okay, so notice that this limit, okay, so this we can actually write sine of, okay, let me write it like this, limit h goes to 0 minus sin h divided by h, so this limit, and again this constant limit. Okay, now we know that this limit exists and this is equal to 1, and because the right hand limit should be equal to left hand limit, which is equal to 1, this implies that,
Sir,
Yes, I
sir,
think I
can
think
we?
this I think this limit is wrong here. Okay, so
Yes,
that
yes.
was the problem, I think.
Sir, can we do like this?
Okay, let me first solve this, then I'll answer to you. Okay, because here you can see that here I'll have this
I think
m pi
there
will
will be
cancel, b will be cancel, and then I will have pi m times h, and then h will cancel, and this limit will become m, right?
M.
Yes, so this limit will become m,
This will -1.
and again we know that m pi plus b is 0, so this quantity is 0 because we have already found out that this is 0 here in
Yes,
equation 1.
yes,
So that will just give you that this limit is -1. Okay,
yes.
so the equality will just imply that m is -1, and then you will have b equal to 1, right? Because m pi is 0. No, b equal to pi. The second option is correct here. Okay, so what you were saying?
Sir, I'm saying, can we do like this? F dash equal to directly when x is less than pi, we can say
Okay,
derivative of
so
cos x, sin x is equal to cos x.
so you want to differentiate the function on the left hand of pi and right hand of pi, right?
Yes, yes, sir.
We
Can
can
we
just say that this is cos
cos
of
x?
cos
Right.
x if x is less than pi, and then you will have just m,
Yes.
x is
X is
greater than
greater
pi.
than pi.
Okay,
F dash both the
but
derivative.
what about at pi? You have to still find m prime of pi, f prime pi, right? This limit we have to must find h tends to 0, f of pi plus h minus
Yes,
f pi divided by h.
yes.
So on the left hand side you can differentiate, right hand side you can differentiate, but at pi we have to still we have to find this limit because we don't know how to differentiate because the function is given in such a way. But it is given
Okay.
that it is differentiable, so that means this limit must exist, and
Exist.
that gives us that when that limit exists, so that what condition can you give? Okay, so you can only have m equal to -1 and b equal to pi. So only minus x plus pi, that linear function will give that the function will be differentiable at pi.
Okay.
So if we know that this f prime is continuous, then you can find out it from here also, right? So if it was given that f prime is continuous at x equal to pi, if this was given,
Okay.
then you can see that the right hand limit and left hand limit in this equation should also be same, right, for this function. So for this function left hand limit, if you take x goes to pi from the left hand side of this function, then this is -1 because the left hand side function is defined to be cos x, and from the right it is m, the constant, so m is -1, and then you can work out for b. But the thing is that it is not given that f prime is continuous at pi, and we know that even if function is differentiable at a point, that doesn't mean that the derivative is continuous, right? So we cannot say that derivative is continuous at pi, because we have these kind of functions like x times sine 1 by x when x is non-zero, and 0 if x is 0. Now this function is differentiable at 0, but its derivative is not continuous. So here f is differentiable at 0, but the derivative is not continuous at 0. Okay, so
Okay.
the, so the continuity argument at this m prime we cannot use actually.
Okay, sir. Thank you.
Yes. Okay, so are there any other questions? Okay, so if no questions, then let's move to the next problem. It says that how many points you can have in, how many real points or the points on the real line you can have, so that this equation gets satisfied. For how many points this equation gets satisfied? Okay, that you have to find out. So so if you consider this function fx, which is sine square x minus 3x minus 5. Okay, so saying that the equation gets satisfied, so sine square minus 3x equal to 5. If in on leaf, fx is 0, right? Because you can see that we just take minus 5 on the left hand side. So basically, you have to find out how many roots or zeros this equation function or equation can have. Okay, so for one thing, we can check its values if it becomes positive or negative on one side, right? If at some if at some point the function value is negative, it's like it's changing sign, and at some point its value is positive, right, and negative. So because this function is everywhere continuous, it must cross the x-axis, right, so that there will be a zero. So f is continuous everywhere, so on the whole real line. So let's find out those points, if like some points where function becomes negative and positive, changes its sign, right? So what about at 0? So at 0, you can see that the function value is minus 5, which is negative. Now we have to just find some point where function becomes positive. Okay, so you can see that this is just sin x whole square and then minus 3x plus 5. So this part is always positive. So if we can make this part negative, then everything will become positive, right? So we have to find such a value so that this part become negative. So what about at minus 1? If we take f of minus 1, so this is sine of minus 1 whole square, and then at minus 1 this is, no, at minus 1 this becomes positive. So let's find out some at some other point at minus 2. Okay, so we don't have to care about sine function because it's already square of sine function, so it doesn't matter if sine function has negative values, the square will always positive. So at minus 2, this will be minus 6 plus 5, which is minus 1. So minus minus is become plus, so this is plus 1. Now this is always positive. So you can see that the function is changing sign in this interval minus 2 comma 0. So f is, we can say that f is changing its sign in the interval minus 2 comma 0, right, the closed interval. So by intermediate value theorem, so intermediate value theorem says that if the function is continuous in an interval and if it takes two values, then it will take every value in between, right? So our function is continuous, it is taking these two values, one is positive and one is negative. That means it has to take all the values between these two positive and negative values, and in between these two, 0 also lies, so it has to take 0. So by intermediate value theorem, there exists some x, let's call it x naught, in this interval. Let's not write real line. In this interval minus 2 comma 0, such that we can say that it lies between open interval, because at endpoints the function is not 0, right? Such that f of x naught is 0. So that means intermediate value theorem gives us that there must exist at least one point at which the function becomes 0, or the equation, this equation has at least one solution. So we can rule out that 0 is not so 0 is not the correct option. Okay, this cannot be correct option, but we have to find if there can be any other zeros, right? So you can see that if there are other zeros, let's say this is x naught 1 0 and this is x1. So if f of x naught is 0, and if there is one more 0 such that x naught is not equal to x1, that means that derivative of this function must become 0 at some point, right? Because the function is again differentiable also. This is also a differential function, so you have Rolle's theorem. So Rayleigh's theorem will say that there is some c in between the interval somewhere such that f prime c is 0. Okay. So let's find out what is the derivative of our function f prime. So you can see that derivative is 2 sin x cos x minus 3. And this we can write as sin 2x, right? Minus 3. Now notice that sine function is always less than equal to minus 1, right? Sine, therefore sine 2x will also lie between 1 and minus 1. So that means this value will always be negative, right? This is negative for every x in R. So the derivative of function is always negative. It cannot become 0. Okay. So because it cannot become 0, we cannot find such a point x1, right? Because if another 0 is there, then it will contradict the Rolle's theorem. Okay. So this we can write. The function f cannot have more than one zeros, as it will contradict the Rolle's theorem. Otherwise, okay. So therefore, f has a unique 0. Okay, so f can have only one 0. So all these options are wrong. So okay, so any questions here?
Sir, uh,
Yes.
where is fx has 0? Can you say about it?
So that
At what point fx has 0?
okay, so you can say something like you can reduce the interval, you can narrow down the interval, but it's not that easy to actually find out where it is this has 0. But
Okay.
at least what you can do, you can draw this graphs, right? So you can have, so what was your our equation? This was sine square x minus 3x equal to 5, right?
Yes, sir.
So that is basically you want to find out where sine square x becomes 3x plus 5, right?
Yes, sir.
Now you can notice that this sine square x, this will be some this kind of graph, right? Because
Yes, sir.
sine square is always positive, and again
Yes.
this is periodic.
Yes, sir.
So from this graph, we can also say that this can have only one zero because 3x plus 5, this is a line
Yes, sir.
with slope 3. So line will just cut your graph at exactly one point. Okay,
Okay.
so it is not cutting at 0 because this is a wrong line, because you can see that the line cannot pass through 0. So
Yes,
basically
yes, sir. Yes.
it's going somewhere. This cutting at only one point. So at that point, the 0 will be there. So you can draw these graphs and find out where it cuts between the interval minus 2 and 0. And precisely these can be done by some numerical analysis methods, right? Because we were saying that the function changes sign, this function, which sine square x minus 3x minus 5, it was changing its sign between minus 2 comma 0 in this
Yes,
interval.
sir.
So what you can do, you can divide the interval in two parts. This is called bisection method. This is a method in numerical analysis. So find out zeros by iterative methods. Okay. So now you know that the here function is something like negative and positive. So you can divide this interval in two parts. This is minus 1, and you can find out what is the value at minus 1. So if it turns out to be positive, that means the root must lie in this interval. And if this value is negative, then root must lie in this interval, right? So like this, you can uh, choose a smaller interval, right? And then again, you can divide the interval in half in whatever interval the zero lie, and you can keep doing this process a lot of times, like 10 times, 20 times, 100 times, so that you can get closer to the zero. You can approximate zero, the zero, like this. So these are approximation methods. Okay.
Thank you, sir.
Yeah. So any other questions? Okay, so let's move to the next problem. Okay, so it's given that if this some function y satisfy this equation, then you have to find out y4. Given that at 1 the function is 0, and at 1 the derivative is as 8, its value is 8, and you have to find the value of the function at 4. Now this kind of problem, you can see that this is a differential equation, right? The double derivative is equal to some function. This is kind of a differential equation, and the one thing you can solve this differential equation, that will be learning in this course later on maybe. But you can guess the function whose derivative is this, or whose double derivative is this. Okay, so how do we do this? Because this is double derivative, we will guess the function in two steps. Okay, so what you will do, you can find out whose derivative is this function, right? So this y double prime, you can see that this is just x to power half plus 3 x to power minus half. Okay, so because you have differentiated this function two times, and you have these kind of powers, and you know that for powers the derivative rule applies like this, right? R times x to the power r minus 1. That means you have reduced this power to half by differentiating this function two times. So if you want to guess from which function this derivative came, so you can go to one previous level. So you can see that if you have x to the power 3 by 2, and then if you differentiate this function, then you will have 3 by 2 times x to the power half, right? So there will be a 3 by 2 factor. Okay, so an x to the power half is there, and you have x to the power half, but you have a factor of 15, and you can only have a factor of 3 by 2. That means you are differentiating something else, right? Not x to the power 3 by 2. So what you can do, if you differentiate, let's see, 10 times x to the power 3 by 2. Okay, so that means there will be a 10 outside, and then now if you cancel out this 10 by 2, then you will get 15 times x to the power half, right? So this thing. So that's how we can guess this. So what we will do, we consider this function, let's call it gx. So what is gx? Gx is 10 times x to the power 3 by 2, right? And plus, now we will guess the second term. So from where this derivative came, right? This must came from x to the power half, right? Because if you differentiate x to the power half, then you will have x to the power minus half, and with a half factor of half. But here you have a factor of 3 also, right? That means there must be a factor of 6. So this is 6 by 2, and then you will get 3 times x to the power minus half, like this. So we will consider this function 10 times x power 3 by 2 and 3 times x to the power minus half. Now if you differentiate this function, then you see that you will get exactly the y double prime, which is 15 root x, because we have constructed this function in that way. No, we have to write 6, right? We have decided that factor will be 6. Okay, so you'll have 3 times x to the power minus half. Okay, now notice that this is same as the derivative, double derivative, right? The derivative of y prime. And So this will imply that g prime x minus y double prime is 0. Okay. So the mean value theorem says that, okay, so what mean value theorem says? So this is derivative of gx minus y prime, right? If you differentiate gx minus y prime, then you will get 0. Okay. So the mean value theorem, using mean value theorem, you can prove that if the derivative of a function is 0 everywhere for every x, right, in the domain of the function. Okay, so if the derivative is 0 everywhere, then by the mean value theorem, the function must be constant, right? Fx must be equal to some constant. So this is the mean value theorem. Okay, so therefore, from the mean value theorem, the MVT, gx minus the derivative of y must be a constant. Let's call it c1. Okay, so this will imply that what is y prime? This will say that y prime must be equal to gx minus c1. And what was our g1? Gx, it was 10 times x to the power 3 by 2 plus 6 times x to the power minus half and minus this constant. Now we can find out this constant using some this values of the given values, right? This first and second. So we'll use that the derivative at 1 is equal to 8. So from using this we will find out what is c1, this constant. Okay, so y prime at 1 equal to 8, that will imply that 10 plus 6 minus this constant must be equal to 8, right? And this will imply that the c1 must be 16 minus 8, which is equal to 8. Okay, so now we have the y prime. Okay, so y prime is equal to 10 x to the power 3 by 2 plus 6 x to the power half minus 8. Okay, now again we'll use the same process, the same method to find y. So, like we have to guess the function for which the derivative becomes this, right? So let's see how we'll guess this function. So consider the function fx. You can see that we have x to the power 3 by 2. So how do we get x to the power 3 by 2? This must be coming from x to the power 5 by 2, right? After differentiating. So if you differentiate x to the power 5 by 2, you'll get 5 by 2 times x to the power 3 by 2. Okay. But we have the factor of 10 here. So we also need this factor of 10. So we have to multiply this thing by some number so that we get this factor. So how do we get this factor? If you multiply by 4, right? If you multiply by 4, then we'll have here also the multiply by 4, and then you will have a factor of 10. So consider this thing, 4 times x to the power 5 by 2 plus, again, if you consider 12 times x to the power half, you can see that its derivative will be 6 times x to the power minus half, and let's consider 8x. Okay. So now if you differentiate this function, you will get precisely 10 times x to the power 3 by 2 plus 12 times x to the power minus half and minus 8, which is equal to y prime. Okay, so this implies that the difference of function f minus y, its derivative is 0. So again, using mean value theorem, MVT, mean value theorem, this fx minus y must be a constant. Let's call it c2. The constant is c2. Okay, now we will find this constant. Okay, so this means y must be fx minus c2. So what is our fx? This is you can say that kind of reverse engineering. You are trying to, yeah, or you are guessing the function from after differentiating. You get y prime and y double prime, right? We are just guessing the function. So what was fx? Was 4 times x to the power 5 by 2 plus 12 times x to the power half and minus 8x, right? Okay, and minus this constant c2. Now it is given that the value of the function at 1 is 0. You can see that this, now we will use this condition. Okay, and we have to find the value of the function at 4, x y equal to, at x equal to 4. Okay, so y1 equal to 0 will imply that minus c2 is 0. Okay, this constant just becomes 0. So the function is, you get that the function is this. Now we have to find at y equal to 4. So at y equal to 4, this is 4 times 2 to the power of 5, right? Plus 12 times, what is the x per half? X per half means the under root of x, which is 4. So under root of 4, which is 2. And here again 8 times 4. So I think there's some mistake. Yes, so we are doing some mistake. So C2 is not 0. You can see that we have to solve this equation for finding C2. If you put 1 in this equation, then you will have 4 plus 12 minus 8 and minus C2. This will become 0, right? That will imply C2 must be, what should be C2? So it's 12 plus 4, 16 minus 8. Again, this is 8. There must be a 8 here. I think there is still a sign problem. Okay, so wait for some time. There is some disturbance in the room. Okay, so are we doing some mistake? Let me check. 15x power half and 3x to power minus half. Then if we differentiate this function, then
6x to the power half. I think there will be half, not minus half.
okay.
There will be half, not minus half, I think.
Yes, I think we decided on 6 times x to power half, then I wrote minus half.
Yes, sir. There will be
Okay.
half.
If you notice this thing before, then please just let me know. Okay. So this must be half. No, this was right. 6 times x to power half. So this creates trouble later on, right? 6 times half here. This is creating problem. Now the calculation of constant is correct because at 1 it's just 10 plus 6, 16, 8. C1 is correct. So 6 times plus half. Okay. And again here it is must be 3 by 2 now.
Yes.
So consider 3 by 2 with appropriate constant. Constant should also be changed. This is x to the power 3 by 2. And if you differentiate this, then you will get x to the power half, right? And then you will have 3 by 2 also. So if you multiply 3 by 2 with something, then you should get 6. So if you multiply 3 by 2 with some constant, then you get 6, right? It must be 4. So if we write here 4, then is it correct? I think it will be correct, right? So here you will get 4 times 3 by 2, which is 6. Okay. That means now our function is 4 times x to the power 3 by 2 here. Here we have 4. 4 times x to the power 3 by 2 and minus 8x and minus again a constant. Now if we compute at 1, then you will have 4 plus 4 minus 8 C2, which is 0. Then C2 must be 0. Okay, so C2 is actually 0. So we don't have this minus 8. And also this will also changed 4 times x to the power 3 by 2. Now if you put 4, then you will have 4 times 2 cube, right? Which is, you can see that this we can write 2 to the power 7, and again this is 32 minus 32. So that will cancel. So 2 to the power 7 must is correct answer here, right? Okay. So did you understand the process of finding the function here? You can see that we have got this function. This is actually, you can say that one of some simple way of solving a differential equation, right? In this case, we are just solving this differential equation by just guessing the solution, what solution can be. That this is a very naive way, and this will not work in a general case where the differential equation is maybe complicated. But this just explains of this guessing procedure. Okay. So any questions? Okay, so let's move to the next problem. So it's given that the derivative of function lies between minus 2 and 2. Okay, so there's a typo. This f should not be here. This is just say that derivative of the function lies between minus 2 and 2. So what is the most values of fx can increase? Okay, so it just asks that how much for the function can increase in this interval. Okay, so that means it is asking the difference between the maximum and minimum value, right? Inside the interval the function can behave in a very different way, something. So it just asks the difference between the lowest value and the maximum value, how much the difference can be at max. Okay, so it just asks the maximum difference, not the exact value. The exact value we cannot find here because the function is not given, but we can approximate that what is the maximum error or the maximum variation in the function. Okay, the difference between the maximum and the minimum value, how much that can be at most. Okay, so for this we apply the mean value theorem, right? So what do we have to find? We have to find for any x1 comma x2 inside the interval, which is 0 comma 6 here, we have to find the maximum of the difference, this difference. We have to maximize this difference. Okay, we have to find this difference, how much can be at most. So for this, we'll just use the mean value theorem. So okay, so mean value theorem says that for any x1 comma x2 in this interval, fx1 minus f of x2 divided by, okay, notice that we are taking this x1 not equal to x2. Otherwise the difference will be 0. So there's no point in that. So this quotient must be the derivative of function at some point, right? Let's call it c. For some point c inside this x1 comma x2 interval, okay. Okay, so we can apply the mean value theorem. Why? Because it's given that the function is differentiable and its values lies between -2 comma 2. So the function is differentiable, it must be continuous and everything, we can assume that. And therefore fx1 minus f of x2, this modulus is just less than equal to, like, so in this case is exactly equal to f prime c times x1 minus x2, right? Now, what is the maximum value of the derivative? You can see that the derivative is given to be lying between -2 comma 2. So if you write this condition, it is says that the derivative is modulus is less than equal to 2. Okay. If you put the modulus, then -2 becomes 2. So the modulus is at most 2. So this is at most 2. And the length of the interval, right? This is the length of the interval on the real line. Somewhere we have this point x1, somewhere we have to have point x2, and the difference just gives the length of this interval. Okay, so the length is equal to this. So length of this interval is x1 minus x2 is modulus. Okay, now this length can be maximum 6, right? Because we are given that this function is differentiable and everything in the interval 0 comma 6, so it can be at max 6, right? So this is 12. So function can increase at most 12 in this interval. The first option is correct here. So any questions? Okay, let's move to the next problem. Okay, so in this exercise, it is given that the two functions are continuously differentiable. Okay, so this is the term we use. So what do we mean by continuously differentiable? This just says that two things, that f is differentiable. Second thing is the derivative is continuous. The f prime, if you differentiate, because that function is differentiable, so if you differentiate, the derivative is continuous. Okay, so these two things, we say that for these two things we say that the function is continuously differentiable. Okay, and it satisfies these two relations, that if you differentiate f, then you will get g, and if you differentiate g, then you will get minus f. Okay, and the function hx is given to be the square of these, sum of the square of these two, right? Okay, so what our given data is given that f prime of x is gx and g prime of x is minus fx. Okay, and we have this function hx, which is fx whole square plus gx whole square. And then we have to say something about this function h. Okay, so what can we say about the function h? So for this, what we will do, we will just differentiate this function. So now we can differentiate, right? Because the f and g both are differentiable, so their square is differentiable and their sum is also differentiable. So, and for differentiation, we'll apply the chain rule, right? And the algebra of differentiability. So the derivative of this sum is derivative of this function, derivative of plus derivative of this second function. And if you want to differentiate the first function, then you have to apply the chain rule, because it's a square of a function. So if you differentiate the square, you will get 2 times the function, and then you have to differentiate the function, that means it is f prime. Similarly, for second function, this is 2 times gx into g prime. Okay, now you can put you can apply this relation. the star relations. So the derivative of f is g. So this is 2 times fx times gx, and the derivative of g is minus of fx. So this is minus 2 times again fx into gx. That means it is equal to 0. Okay. Now since the derivative of this function h, so this is h, is 0 everywhere, whatever the domain. So there is no domain specified. So we can write that it is 0 everywhere. By mean value theorem, again by mean value theorem, this h must be constant, right? It must be a constant function. Okay, so that we can conclude from mean value theorem for about this function. And according to that, which option can be correct or which options can be ruled out. Okay, so you can see that we can rule out this option, right? Because it's saying that at 0 it is 5, at 10, okay, we cannot rule out this one. Let's see. But we rule out this second one, because at 0 it is 10, at 5 it is 5, and that cannot happen, right? Because the function must be constant, so it cannot take two different value. Similarly, this also rules out because it is taking two different value. So now we remain with these two cases, that at 0 function value is 10, at 5 function value is again 10, and at 0 function value is 5, and at 10 the function value is 5. So both are constant value, so we have to find out which one can be true out of these two. Any idea? So I think from this we cannot conclude anything more. The both options are actually correct. Okay, so the function can be anything. So I think in this case we have to say that both options are correct. So first is also correct and second is also correct, right? Because the function can, the h is a constant function, and it can be the constant function 5 or constant function 10. Okay, it can be the both of these things. Okay, so if you have noticed this, you can see that we have actually these kind of functions where the derivative of one function is another function, and the derivative of the second function is the negative of first function. Okay, so if you take this function fx sin x and gxh cos x, right? You can see that the derivative of f is cos x, which is the first function, and the derivative of the second function is minus sin x, which is the negative of the first function, minus of fx. Okay, so they satisfy these kind of relations. So if you see that, if you see what can h be, so h in this case is sin square x plus cos square x, which is equal to 1. So you can see that the h is constant, and which is just constant 1. Okay, so this constant you can take anything. Okay, so if you want to have some other constant, then you can just multiply here fx as c times, or constant times sin x, again constant times cos x, or let's write this constant as d. Okay, then you will have again same kind of relations, and this hx will be just equal to d, right? Or d square. It is not d, it will be d square. So you can have d square and d square. Okay, so that means basically we can have both constant. So the constant can be 5, or it can be 10, or it can be anything. So both options are correct, I think, in case. So I think both a and b are correct. So we can say that the d option is also correct. So any questions here? Okay, so no questions. Then let's move to the next problem. Okay, so you have to find the value of this function which is at x equal to 1, right? I don't know. Pen is not working. What is happening? Oh, my pen is not working because I have changed the color to white. Okay, let's change it again. Blue. It was working, but it was writing in white. Okay. So you have to find what is f of 1. Okay, so you can see that 1 lies in this interval. 1 is greater than equal to minus 1. Okay, so that means the what value, so what can be the value of 1 at f of 1? It must be a plus 2b plus 1, right? Now to find this value, you have to find these values of a and b. Okay, and it's given that the function is differentiable for all values of x. It's differentiable everywhere. Okay, so we'll use this differentiability condition. Let's write what is the function. Ax plus b if x is less than minus 1, and ax cube plus x plus 2b when x is greater than equal to minus 1. Okay, now since function is differentiable everywhere, that means it is differentiable at x equal to minus 1, and therefore also continuous at x equal to minus 1. Okay, so what is the value of function at minus 1? So at minus 1, the value of the function is a minus 1 plus 2b. And also, if you take the left hand limit at minus 1, because it's continuous, so left hand limit at minus 1 must be equal to the function value. From the left hand side, you will get that the limit is minus a plus b. Okay, so this implies that these two must be equal. Since f is continuous at x equal to minus 1, we must have minus a plus b to be equal to minus a minus 1 plus 2b. So you can see that this a will cancel out on both sides, and it will at least give us what is the value of b. So value of b must be 1. Okay, so the value of b is 1, but we have to find the value of a also. For that, we will use the condition of differentiability at x equal to minus 1. Okay, so now since function is differentiable at x equal to minus 1, so we must have that these limits are equal. What are those limits? F of minus 1 plus h minus f of minus 1 divided by h. Okay. So this is just the right hand limit, and this must be equal to the left hand limit. Okay, so here this time I'll write left hand limit in this way, where f of minus 1 minus f of minus 1 minus h and divided by h. Okay, so here I'm taking h to be positive even in the left hand side limit. So these two must be equal, and therefore we'll just apply the definition of, we'll just apply this definition. Okay, let's first find out the second limit. Okay, first we'll find out the second limit. So limit h tends to 0, f of minus 1 minus f of minus 1 minus h divided by h. Okay, so notice that h is positive, and since h is positive, minus 1 minus h, this thing. Okay, so it minus 1. Okay, so okay, so at minus 1, what is the function value? It is minus a minus 1 plus 2b minus a minus 1 plus 2b, and at minus 1 minus h. Okay, so you can notice that minus 1 minus h is strictly less than minus 1, right? Because h is positive. That means you have to apply the first definition of the function, this linear one, ax plus b. So if you apply that definition, you will have that it is equal to a times minus 1 minus h and minus b, and then we'll have divided by h. Okay, what is this limit? Can we say something about this limit? Limit h goes to 0, we can cancel out something. Okay, so minus a minus 1 plus 2b, and then we'll have minus a, which will become plus, and again plus a times h and minus b, and divide by h. Okay, so this a will cancel with this one. So limit h goes to 0, we'll have 2b minus b, which is b. So we'll have b minus 1 divided by h plus a, right? This we have. Now since this limit exists, we must have b minus 1 to goes to 0, right? As this limit exists, this implies that b minus 1 must be 0, and this limit turns out to be equal to a as s tends to 0. Okay, okay, so this implies that b must be equal to 1, which we already knew. Okay, so b is equal to 1 we already knew, so there's no point of writing this, that b is equal to 1. Okay, since b is equal to 1, this limit is equal to a. Okay, now we'll evaluate the second limit, the right hand limit. Limit h goes to 0, f of minus 1 plus h minus f of minus 1 divided by h. So what is this? Limit h going to 0. So we have to take the cube of minus 1 plus h, right? Because on the right hand side, that is the definition of the function. It is a times x cube. So there is a also. A times x cube plus x plus 2b. So plus minus 1. Minus 1 plus h plus 2b, and then we have to subtract the value of function at minus 1. So at minus 1, the function value is minus a minus 1 plus 2b, that is a plus 1. So if you subtract, then you will get a plus 1 minus 2b and divided by h. Okay, so if you expand or you don't need to actually expand this, so this 2b will cancel, right? This 2b will cancel, 1 will also cancel with minus 1. So what will be left? We're left with a minus 1 plus h cube plus a plus h and divided by h. Okay, so notice that if you actually open this bracket, then you will get that minus 1 to the whole cube, which is just minus 1, and that will cancel with a. Okay, and then there will be higher powers of h, right? If you expand this, only the constant term is minus 1, so that will just cancel with a, and other terms will always contain h. And if you take the limit as h tends to 0, then everything will become 0. This limit is exactly equal to 1, right? Because you can divide this h by this h, so the limit is exactly equal to 1. Or we can write it like this also, right? This is divided by this plus 1. Okay, so this whole limit, this limit just becomes 0, and you will have 1. And initially we were getting that the limit is a, so this implies that a must be 1. Okay, we can say that since f is differentiable at x equal to minus 1, a must be 1. Okay, so now we get that a is 1 and b is also 1. So now we can tell what is the value of 1, f of 1. Okay. So what is f of 1? It must be 4, right? Again, are we doing some mistakes in taking this limit? Okay, let me write out this explicitly. We will have a times minus 1 plus h cube plus 3 times, okay, no, okay, 3 times h. Okay, so there is a mistake, I think. You will have some non-zero limit from here also. So because you have a power, you have just h here, and then you will have minus 3 times h square. This you have in the bracket, a times, okay, and plus a divided by h, this you had. So minus a and plus a, that will get cancelled, and then you have high enough powers of h. But this 3h divided by h will give you 3 also, right? So this limit is 3, not 1. No, it's not 3. You have a also outside in the bracket. The limit is 3a plus 1. This is the limit. Okay. Okay, so this, it is differentiable, then that means 3a plus 1 must be a. This will imply that a must be equal to half or minus half. It is minus half. So a must be minus half. Now a is minus half and b is 1. So this is 3 minus half. That is 5 by 2. Okay. Hence f of 1 plus 1 is 5 by 2. The last option is correct. Okay. So any questions?
No, sir.
Okay, so let's move to the next problem. Okay, so we have another function given by this, given by this partition. So it has 3 different definition, and it's said that the function satisfy hypothesis of mean value theorem on the interval 0, 2. Okay, so what is our function? Let me write once. It's 3 at 0. It's constant 3 if x is 0, and it is minus of x square plus 3x plus a if x lies between 0 and 1, and then you have cx plus b. if x is greater than equal to 1 and less than equal to 2, right? Okay. And it says that the function satisfy the mean value theorem. Okay, so what are the conditions of mean value theorem on the interval? It says that first condition is f is continuous on the interval 0 comma 2 close. The second condition is f is differentiable on the open interval 0 comma 2. Okay, so using these two conditions we have to find out the values of this function. Okay, so you can see that inside the interval, if you see just the open intervals 0 1 and 1 and 2, inside interval all these conditions get satisfied, right? The function is continuous and differentiable and everything. We have to just check at endpoints, because at endpoints the function is changing its definition, right? On the one hand side it is defined by a quadratic function, on the other side it is defined by a linear function. So these things we have to check at all the endpoints. So how many endpoints we have? 0 1 and 2. So there are these three endpoints. So you can see that function is continuous on the closed interval. Okay, so because the function is continuous on closed interval, and that means it must be continuous at 0, but because at 0 it is just defined after 0, so you can just take a right hand limit, right? So that means the limit, the function, if you take the right hand limit, h goes to 0 or x goes to 0, fx, this right hand side limit 0 plus, that must be 3, right? Because at 0 only the function is defined on the right hand side of 0, so you can only take the right hand limit. So this will just imply that. So what is the right hand limit? Because on the right hand side of 0 the function is defined by this quadratic equation, right? So if you find out the limit, you will get a. That means a must be 3. So this is our first observation, that a is 3. Okay, now we don't have to check it at x equal to 2. Okay, because at x equal to 2 there is no partition. The partition was happening only at 0, right? Because at 0 the function was changing its definition. It is not changing its definition at the right hand side of the interval at 2. Now we have to just check it on this 1. So because at 1 the function is also continuous and differentiable. Okay, so we have to use those conditions. So f is continuous at x equal to 1. So the continuity will imply that again the right hand limit and left hand limit must be equal to the functional value, right? So what is the right hand limit in that case? That is, as x goes to 1 minus of fx must be equal to limit x goes to 1 plus of fx from the right. Let me add a new page, and then this will just imply that because on the left of 1 the function is given by this quadratic equation, so if you take the limit you will have minus 1 plus 3 and plus a, right? You just put the value minus 1 in the equation, so we'll have minus 3 actually, because 3 times x. So this is equal to the right hand limit. So for right hand limit you also put x equal to 1. Okay, we are putting x equal to 1, so it is plus 3, not minus 1. So at x equal to 1, what is the right hand side limit? It is c plus b. Okay, so this gives us, so we got the value of a also, right? A was 3. So can we put the value of a? Okay, let's not do that. We just have that c plus b is equal to, let's put the value of a also. A is 3, so it will have 3 plus 2, 5. So c plus b is 5. What else can we do here? You can see that c plus b must be 5. So this option is correct. This option must be wrong, right? Because it just gives that b plus c or c plus b is minus a, but a is 3. So that is minus 3. And but we get 5. So that means this is wrong. Again, this is also wrong because b plus c is 5. That is not equal to a. So that option is also wrong. And others we cannot verify now, right? We don't have enough information to verify other two options. So let's use another constraint, right? This was the constraint that f is differentiable. We have not used the differentiability at x equal to 1. So now we use the differentiability of the function at x equal to 1. Okay. Since f is differentiable, so for that we have to find the right hand limit and left hand limit of the derivative, right? Not derivative of this thing. At 1 plus h minus f of 1, we have to find this limit. This is the derivative of the function at 1, right? So what is this limit? So notice that I'm taking h to be positive. So if h is positive, this 1 plus h is greater than 1, right? So it's greater than 1, we have to apply the second definition of the derivative, that is linear one, this one. So you'll have c times 1 plus h plus b minus f of 1. So what is f of 1? Okay, so we can check also the continuity at x equal to 1, right? We have not checked. Okay, we have checked the continuity. So from the continuity, we got c plus b equal to 5. Okay, so now we are checking the differentiability. So what is the value of function at x equal to 1? It is b plus c or c plus b. So you just subtract and divide by h. Take the limit as h goes to 0. You will have c, right? Because c will cancel, b will cancel, and c plus s divided by h, that is c. This is the limit, right hand limit. Now we find the left hand limit. So if you find left hand limit and take h to be positive, then you will have f of 1 minus f of 1 minus s. So this is the left hand limit. Again, what is f of 1? It is c plus b. And now we have to subtract f of 1 minus h. So what is f of 1 minus h? Notice that 1 minus h is less than 1. Okay. In this case, because h is positive. So 1 minus h is less than 1. So we have to apply the second definition of the function, which is quadratic one. This quadratic. And it is minus of x square plus 3x plus a. And we have another minus sign on outside. So this minus sign for first one is become plus 1. So 1 minus h whole square, 3x minus a. So minus 3, 1 minus h minus a divided by h. This we have to take limit. So what this limit can be? You can see that we have already found the value of c plus b, right? C plus b is 5. So we can just put c plus b to be 5. And then we'll have minus 3 plus 3 times h and minus a plus. So do we have value of a? We also have value of a. A is equal to 3. So instead of a, we'll just write 3. Okay, and now we open the bracket. This is 1 plus h square minus 2h divided by h. Take limit, h goes to 0. Okay, so still we have to simplify a little bit. So this is equal to limit h goes to 0. Okay, so how much we have? 5 plus 1, 6, 3 minus 3. So all these things will cancel with each other, right? 6. And then we have 3h minus 2h, which is just equal to h, and plus h square, and then divided by h. Then if you take the limit, you will get 1. So the limit is 1. So the function is differentiable. That means c must be equal to 1. Okay, hence c is equal to 1. Now we have c to be equal to 1, a equal to 3, and c plus b equal to 5. So this implies that what is b, because c is equal to 1 and we had that b plus c equal to 5. So this will imply that c is equal to 5 minus or b. The b is equal to 5 minus 1, which is 4. Okay, so now we have all the values and now it's time to check. Okay, so a is 3, c is equal to 1, b is equal to 4. Okay, so if you add a plus b, what do you get? 7, which is not equal to c. So this option is also wrong. What is a plus c? Is 4, which is equal to b. Okay, so third option is correct here. So any questions? Okay, let's move to the next problem. So in this problem, you have to find number of points for which this equation gets satisfied. Okay, so let's me define this function fx, which is this cos square x minus 12x minus 13. Okay, so you can see that the equation will get only if the equation gets satisfied at some point, that means the function must become, the point must be just 0 of this function. Okay, that is the cos square x minus 12x equal to 13 if and only if fx is 0. So we have to find out when, how, at how many points the function can become 0. Okay, so what we'll do, you can see that this function will certainly changes its sign, right? It will change its sign. Let's find its sign at 0. So what is f of 0? So cos 0 is 1, so that is 1, and then it's minus 12 and minus 13. You can see that this is negative. No, so this is just become 0. Okay, it's still negative. Okay, so at 0 it is negative. So can we make it positive at some point? What about at x equal to minus 2? Okay, so if you take its value at x equal to minus 2, you can see that the cos minus 2 is just the square, because so this is a positive value, and then at minus 2 you will have plus 24 and minus 13. Okay, you can see that this is positive, right? So the function is continuous everywhere, everywhere, and f changes its sign, right? In the interval in which interval is changes its sign, in minus 2 comma 0. Therefore, what can we say? We can say that by intermediate value theorem, which is, we can write it IVT, by intermediate value theorem, there must exist some point x naught inside the interval minus 2 comma 0, such that we can take them open interval, such that f of x naught becomes 0. Okay, so that means there is at least one solution of this given equation. So at least one solution of the given equation is there, but can we have exactly one solution, or can we have more than one solution? Okay, that we have to find out. So for that, let's find out what is the derivative of function. Okay, so this kind of question I have already discussed before. So what is the derivative? It is just minus 2 cos x sin x minus 12. Okay, so this is minus 2. Okay, not minus 2, it is minus of sine 2x minus 12. Okay, so if we take the minus common, it is just 12 plus sine of 2x. It is certainly negative, right? Because the sine 2x lies between minus 1 and 1. Okay, so sine 2x lies between minus 1 and 1. That means the derivative is negative. Okay, so this implies that there can be no zeros, right? So this implies that f has a unique zero. Why? Because if it is had more than one zero, otherwise it will contradict the Rolle's theorem. How? How will it contradict the Rolle's theorem? Because this I have already explained once before also. Because at x0 the function becomes 0, and assume that at x1 the function becomes 0 at some point. Okay, so f of x0 was 0. Assume that there is another 0 such that x0 is not equal to x1, and the function is differentiable, right? This is just a combination of cos and polynomial function. If f is differentiable, so by Rolle's theorem, f prime of c is 0 for some c lying between in this interval x0 comma x1. Okay. Or x1 comma x0, whatever the sign. But that cannot happen, right? Because the derivative is 0, f is less than 0, it cannot become 0. Okay, therefore the function has a unique 0. So any questions? Okay, I think there are no questions. Let's move to the next problem. Okay, so it's given that a function satisfies this equation, that its double derivative is given by this whenever x is positive, and these two values are also given, that at 4 the function is 0 and at 1 this derivative is 18, and we have to find the value of the function at 9. Okay, so for that we will again do apply the same method which we have used in the previous same kind of problem, that reverse engineering method, that guessing a function, we will guess a function and then investigate. Okay, so let's so what is y double prime? Let me write all the information. It is 2 times x to power minus 3 by 2 and plus 9 times x to power half, actually minus half, and then y prime. Okay, so here x is positive because the root function requires that, and y prime of 1 is 18, y4 is 0, and we have to find y of 9. Okay, so what we have to find? We have to find y of 9. Okay, let's consider the function fx. Okay, so we are finding some function whose derivative is equal to y prime. Okay, not the y double prime. No, we will find some function whose derivative is equal to y double prime. Okay, first we will go one step before. So we will guess a function so that its derivative becomes this y double prime. Okay, so consider this, the function minus 4 x to power half minus half plus 18 x to power 3 by 2, right? Okay, not 3 by 2, half. Okay, so we are guessing this function on the basis of that if you have a constant c and you have a constant x to power r, so if you differentiate this, then you will get c times r x to power r minus 1, and we are guessing this power and constant, both the things, right? Because we know the derivative. Okay, so we want that after differentiation we will want that it should come out 2 times x to power minus 3 by 2, and on the basis of that we are guessing this function. So if you see that if you differentiate this function, then we will exactly get 2 times x to the power minus 3 by 2 plus 9 times x to the power minus half, okay, which is just equal to y double prime. So this implies that if you take the difference of f and y prime and differentiate this function, then you will get 0, right? So this holds everywhere. So again, by the mean value theorem, the y prime must be f plus some constant c1. Okay, let's write this some c1. And now it's given that at 1 the y prime is 18, so that we will apply that condition that at y prime of 1, which is f of 1 plus c1, which is 18, right? From this we will find the value of the constant c1. So what is f of 1? So you can see that if you put 1 in this function, you will get minus 4 plus 18 plus c1 is equal to 18, and this will imply that c1 must be 4. Okay, so we got the c constant c1 to be 4, and therefore we got the y prime. So what is y prime? It is f plus c1, which is 4, and what is f? It is minus 4 times x to the power minus half plus 18 x to the power half plus 4. Now we'll consider another function whose derivative becomes y prime. Okay, so how are we going to guess such a function? Consider this: 12 times x to the power 3 by 2 and plus 4x. Let's see what do we get after if you differentiate this g by x with respect to x. And you can see that it will exactly give us minus 4 times x to the power minus half plus 12 times 3 by 2, which is just 18 times x to the power half and plus 4, okay, which is just equal to y prime of x. So this implies that if you take the difference, okay, this time let's take the difference y minus g. So if you take this difference and differentiate this, then you will get 0, right? Because if the derivative are equal. So again, by mean value theorem, y must be g plus some constant c2, and this constant we will find out what this constant can be. So it's given that at 4 the function is 0, right? So y of 4, which is g of 4 plus c2, this becomes 0. This implies that c2 must be minus of g4. So let's find out what is g4. So g of 4 we can find out using because we know the definition of function g. So what is g of 4? It's minus 8 times square root of x, which is minus 8 times 2, and plus 12 times the cube of the square root of x, right? So the cube of square root of x, which is 8, right? And the root of 4 is 2, and then you take a cube, and then you have 4 times x. So 4 times 4, 16. Okay, so let's simplify this. Minus of, so this 16 will just cancel with this one. Okay, and then we'll have just 12 times 8, which is 96. Okay, so we got the second constant also. So what is the function? So our function y of x, which was g plus constant, we can write it now, right? This is minus 8 x to the power half plus 12 times x to the power 3 by 2 plus 4x, and now we have the second constant, which is just minus 96. and we have to find its value at 9, y of 9. So what is y of 9? Notice that 9 to the power half is just 3, right? It's a square root of 9. So we'll apply, use that. So minus 8 times 3 plus 12 times the cube of the square root, which is 3 cube, right? 3 cube is 27 plus 4 times 9, which is 36, and minus 96. Okay, so you'll have 24, 36, 96, and what is 12 times 27? 324. Okay, so just add all these things. So minus 120 plus 360. So if you subtract 120 from 360, you'll have 240. Okay, the second option is correct here. So any questions? Okay, so no, if there are no questions, then let's move to the next problem. So this is again the similar problem. It's given that the derivative of the function lies between minus root 2 and root 2. That means the maximum modulus of the derivative can be root 2, and it asks that how much can the function increase in the interval 0 comma root 2. Okay, that means you have to find that for any x1 and x2 inside the interval 0 comma root 2, such that x1 is not equal to x2, or even if equal to, doesn't matter, you have to find out what this maximum can be. Okay, so using the mean value theorem, this you can write as the derivative of f prime c at some point into x1 minus x2, right? By mean value theorem, where c belongs to the interval x1 comma x2. Okay, so we are just assuming that x1 is less than x2. So you can see that this is maximum root 2, and the length of the interval, this is the x1 minus x2 means the length of the interval x1 comma x2, but the maximum, the length can be root 2 minus 0, right? This is just 2. So the function can increase at most 2. So the last option is correct here. Okay, so that's all. Are there any questions? Okay, so I think there are no questions. So we have finished solving this week's assignment, or this week's problem set. Thank you everyone for joining. So we can end our live session at this point. We will meet next week with a different set of problems. Let's sign off now.